everyone, today we're looking at exponential functions. So exponential functions define relationships where the ratio of successive values for y will be constant. So to explain this, we can look at y equals 2 to the power of x. So for this table of values here, when x is 0, y would be 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. When x is 4, y is 16. 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. In each case, the ratio is the same. It has a constant first ratio of 2, indicating we have an exponential function. An exponential function has the form y equals some initial value times by a to the power of x, where a is the constant ratio, y0 is the initial value at x equals 0. That's what this little 0 down here indicates. And x is your x value. So, for the pattern 3, 6, 12, 24, 48, the initial value is 3. It's doubling each time. The equation would be y equals 3 times 2 to the power of x. And we can test this. If x was 0, 3 times 2 to the power of 0 is 3 times 1, would be 3. 3 times 2 to the power of 1 would be 3 times 2 is 6 for the first value, for the value x equals 1. If we put x equals 0, x equals 1, x equals 2. And for 12, it would be 3 times 4, which would be 12. So there you go, it works. And I've shown that here. Now, an exponential graph has a characteristic shape. If we've got one that's growing, it'll start at an asymptote and it will gradually increase and go off to infinity. If it's a decaying equation, it will start at positive infinity and work its way down to an asymptote, which is shown here. Now, the growth equations have a constant ratio that's greater than 1. So multiplying by 2, multiplying by 3, so on and so forth. If the ratio is between 0 and 1, like a fraction, a half, it will decrease. And repetitively we're halving it, or quartering it, or thirding it, or some value between 0 and 1. Now, transformations can apply to exponential graphs. So if, like with any other function, if we subtract k, it's going to move it vertically. Actually, I might just change that because I was referring to it differently later. Make this h. Actually, I think I left that as k and I made the other one h. Right, there we go. So if we subtract a value from the exponential part, it's going to move it up and down. If we subtract from the index, it will move it left and right. So when we're trying to find an equation from a graph, we should consider a few things that will help us. And the first one is, where is the asymptote? If the asymptote's at 0, it hasn't been moved vertically, which makes our life a lot easier. If it has, we'll have to consider that later. Next, we're trying to figure out what's the common ratio. Can we find out the value of a? Then, is the graph facing left or right? Probably a better way of saying that, after discussing this with colleagues, is to say, is it growing or decaying? So are the numbers getting bigger or are they getting smaller? And how should the translation be applied? What are our h and k values? Excuse me. Right. So in this case, using our 4 ideas, it's growing, so we know the value of a is going to be greater than 1. where's the asymptote? Well, it's at 0, so there's no vertical translation, which is great. Now we're trying to find the common ratio. So we need to find 2 points for y and divide them. So this is 3, this is 1, 3 divided by 1 is 3. We can check it here, 1 divided by a third, that's still 3, indicating to us that our a value is 3. So that's nice and easy. Found the common ratio. Now, we're looking to see, has it been translated horizontally? To do that, we're looking for a point on the curve 1 unit above the asymptote. So here's the asymptote. Here's a point that's 1 unit above, indicated by this blue thing. Now, once we've found that point, have a look and see how far that's been translated from the y-axis. So in this case, it's been translated 2 units horizontally. H will be 2. Now that we've got that, we can write our equation. There's the common ratio, there's the translation, there's the equation. Beautiful. Looking at the next example. In this case, we can see that the asymptote's below the x-axis, indicating to us that it's been translated down. So we have a k value of -2. Once we've got that, according to our little set of things to consider, what's the common ratio? So find some points. Y value is has increased by 2. Here it's increased by 1. Divide the 2 increases, we get 2. Do the same for the next 2. We've got a point here of 1. I'm not sure what this next point is. I think I was lazy and just said, alright, well, I've got the common ratio now, I'm not going to worry about it. If we looked at the next one, it would be 4, is it? Where is it? 4. 1, 2. There, I haven't got it marked on my map, that's why. Oh, yes, I have. Here we go. Between 2 and 6 is 4. I'll put it on. There it is there. So this time it's increased by, oops, it's pretty ugly. Let's fix that up. Down to here. The next increase is 4. 4 divided by 2 is 2. 2 divided by 1 is 2. Each time it's doubling. So a is going to be 2. Find the asymptote. Go 1 unit above it. The gap between that point and the y-axis is 2, indicating it's been moved 2 units to the right. And so now we have all the values that we need to make the equation. Y equals 2 to the power of x minus 2 minus 2 again. And there we go. There's a quick look at exponential values. Thank you, everyone.